Hello, folks. I'm Maciej. And
I'm Maciej.
I will tell you what we learned about growing data science projects. First of all, there is an MIT study telling them that 90% of GenAI projects failed. At Chattermill, we surely contributed to this number. And this is surprising because we have over a decade of experience of delivering very good ML-based features pre-LLM. We have an experienced team of both engineers and data scientists. And as a company, as an organization, as on the individual level, we are very experienced. Yet we managed to fail in short period of time a couple of projects, AI-based. They were so unstable that they required rework. Because of this, they were late. And when we released them to production, some of them appeared to be surprisingly expensive. And the surprise was so much that we had to cancel those features. It's kind of embarrassing, right? And the great structure of our team shattered because of those failures. And we are here to tell you what happened, to share what we learned, and also to share what we do now, because of course we don't do it. It forced us to change the way we work. But before we tell you about the details about the crisis and the learnings, we need to introduce some context.
Hey, morning everyone. So in terms of context, let's start with like the sort of pre-LLM era, because Chasm has been around for about almost 10.5 years. And we started off with like smaller neural networks before like AI was sort of a hype. And yeah, we sort of gone to a pattern that was very different to what we are doing now from a lot of our learnings on failures recently. So to start with the metaphor of the garden wall, initially data science, on sort of my side and like engineering, more Maciej side, were very, very much kept apart. They're very much distinct silos. I mean, yeah, we did talk to each other, obviously, we're in the same company, but that was for a reason. And it was actually a rational decision choice. When, in our experience, when a startup is fairly young, you want the research team, like on the data science side, to be able to experiment, fail rapidly, fail very often, succeed very little a lot of the times. That's research, that's life, and sometimes it sucks. But and critically, we have two founders, Michal, Dimitri. One used to look after engineering, the other one used to look after data science. So we also had very strong cultures in both those engineering and data science teams. Now, one of the main differences between data science and engineering, for example, when I joined roughly 6 years ago as an employee, was data science, I was told, was going to deliver things potentially every 6 months. And engineering was on sort of weekly cadence of sprints and delivery. Two sort of never really talked unless like something really was like working and there was more luck than sort of management. However, even though, so I came from a very different background from bigger companies, but I realized that actually that was really, really needed in order to protect some of the early ideas that Chattermill was exploring. So, we were dabbling with neural networks sort of 11 years ago, which not many people were doing, right? And we were doing things like aspect-based sentiment analysis, so analyzing data in a very specific way using much smaller word models, not even language models, I'm saying word models specifically. And sort of understanding that neural networks were the future for understanding text. That was like obvious to our founders. So we've had this sort of fairly long history, but in the sort of spirit of trying to protect these early ideas, in the current era, in the last maybe two or so years, we realized that a lot of our strengths from the sort of last decade were now becoming hindrances. So cracks were slowly appearing, and yeah, we had to sort of figure out what to do next.
Yeah, about the cracks. I joined Chattermill about 3 years ago, so it was on the verge of the LLM revolution, so I saw the old ways going. And as a software engineer with over a decade of experience, I noticed some things that were weird to me. Still, I also knew that the team worked very well. Those were like cracks on the structure. One that I quoted on the slide is, if something was failing on production, from time to time we weren't able to check it to know that it's failing until much later, because and it was okay because we were doing mostly batch processing. Some of the API designs, the contracts between data science and engineering was clunky, and it was hard. They were hard to change. And at times we were releasing something to production which was very well tested, both on semantic level, on engineering level. Yet when we released it, it was a great demo, but it wasn't very useful for the users. And then we iterated on the same feature, and it was still not very useful for the users. And it was a nasty surprise in production. But still, there were some cracks, but the team was working, and it was working like a relay team. It was actually a relay race. The data science was preparing something and passing the baton to engineering, and the engineering responsibility was to take it through the finish line. And it was working fairly well until the environment has changed.
And on that note of the environment changing, the metaphor we'd use is it was almost like a Cambrian explosion, right? So 540 million years ago, all of a sudden, over a 20 million year period, sort of organic diversity changed, different life forms and different structures. And the sort of era I think we find ourselves in right now in AI or ML or more generally is this idea that there's so many different avenues, especially in machine learning, that it's very hard to sort of say that like what worked previously works now. So in terms of very specific concrete things, we notice specific timescale. So yeah, the LLMs change everything. We've heard in some of the keynotes how AI is changing the coding, but also research, right? So a decade ago, a research scientist like myself would have worked weeks, if not months, on one specific eval, right? And now, maybe not daily results, but in some cases for small experiments, updates can be daily because of a lot of agents that have done things in parallel. So this sort of evolution isn't sort of, at least in my view, sort of a gradual thing. It's sort of just happening straight away. And I'm noticing this across the board, not just in business, but also in academia. And what that means is essentially you don't have the luxury of 3-4 months, but you have the luxury of doing a lot more exploration very rapidly. So the trade-off between exploration and exploitation is sort of shifting towards you can explore maybe 20 paths, and instead of in the past exploring 3 and sort of having to bet, I think these 3 are right, because these days AI science or AI scientists, it's a hard science because we don't have laws, etc. So a lot of it is guesswork. Scaling was guesswork. The whole transformers architecture from Google, etc., was guesswork that sort of led to a revolution, right? So it's very hard to sort of say, we are confident about these particular paths. So this exploration is what we're sort of leveraging a lot more and doing a lot more of at Chattermill. And also, what doesn't work as much these days is sort of saying, we know ML really well because we do it as sort of our background. But actually, in the new world, so many new, not necessarily frameworks, but so many new approaches, etc., are appearing that if you're sort of stuck in your old ways of doing things, because that's what you did for the last, even let's say 3 years in ML or AI, that doesn't necessarily mean it's useful for the future. So there's this sort of and more technical note, classic sort of microservice architecture assumptions have been violated as well. And that's where, things started to sort of fall apart between data science and engineering on projects.
And the cracks that we had, the cracks that I noticed when I joined Chattermill, actually developed more into a chasm when the speed increased and when the pressure increased. And if I were to use a metaphor, when you are a software engineer working with the data scientists, it's like an Englishman in New York, because the language is the same, but the culture is very different. Because, I speak British Python, but they speak Pandas Python. So it's hard to understand. And more than that, when we talk about performance, I think about the latency, and the data science think about the semantic performance of a model. But it wasn't the biggest issue. The biggest issue was actually hidden. When I say that my work is done, it means that it's tested, that it's observable, that it's scalable, and probably that it's on production. For the data science, the implied definition of done is much different, because the ML people are more focused on the semantic performance, on the F1 score, on limiting predictability. And because of this difference in what done is, they cooperation within the team could be very hard. And the chasm between the two parts of the company was growing. And if you have a chasm ahead, it is a danger. And unfortunately, we haven't noticed it at time.
And on that note, in terms of the hidden danger, because a lot of the times it's not even perceptible to us, I would say there are many things, especially like around elevated expectations. And this is one of the biggest pitfalls I find currently. And there's this sort of chain of massively overpromising, not just by board members, investors. As a chief scientist, I can say like there's not a single week that goes by where like our investors aren't pressing us on. So how much has AI increased automation here, or in data science or engineering? Are you still doing stuff manually? I'm not just talking about that hype, but I'm just talking about the fact that when you show a demo from research, like my assumption is that A, my code is throwaway, because usually my code is throwaway. But B, the assumption is that this might not work in production. This is a research idea. However, the risk these days, especially like when you show the product, but also like other users, let's say our product shows it, not necessarily me, is that, oh yeah, we want exactly this and we want it sort of like tomorrow. So this whole idea of like, yeah, it basically works and just get some agents to just code it, right? Is a very common thing I hear these days. So in terms of like expectations being elevated, like if you look at the Gartner sort of hype curve, I don't know where you think AI currently is. I've been working on, I've been coding neural networks since 2005. And I never thought like I'd find the day where I'm kind of sick and tired of the term AI. But I think we're not at the peak of the hype yet, right? We've had boom and bust cycles, but right now we're not at the peak for sure. So what that means, I think, is like we're going to see more of that pressure, but we're also going to see more pressure to have to deliver under like increasingly small timelines. So I think in terms of what the quality of the product is, that becomes so much more important than a research paper or whatever, like the quality that we report on. So yeah, demos are sort of our tours, but like actually living there is what we care much more about, which is like the production system overall. And then the last point, specifically around complex interactions. One of our biggest learnings, and my biggest learning, sort of eating humble pie, is that when something works in a sort of outside Streamlit app that data science have worked on, and I mean, I introduced Streamlit like 6 years ago, and I loved it until like now Claude Code can just do the UI, and I don't know how it did it, but whatever, it works. The key thing is interactions in Streamlit don't simulate what our users actually care about in a developed product like Chattermill with all of its functionalities. And the difficulty is, product will say, oh, that looks really great. And then you put it into production and everything changes because it's a lot more data, but also like many more functionalities that interact with it. Those interactions are where like our AIs add most value, right? So essentially, like what data science a lot of times does at Chattermill, but other places as well, is look at things in a sort of lab sort of condition, and it might look really good, but that sort of I've kind of learned quite lately is kind of useless. And the sort of what product has been telling us, both engineering and data science, is like, we want to see it in the product. So that's where like, we started cloning orgs, with obviously engineering help, and testing ideas in those cloned orgs instead of, let's say, a Streamlit app. We still use Streamlit sometimes. But yeah, and I think that will increase as more and more people sort of say, oh, no, we see this demo, so it should be ready by like end of the week. And I get a lot of pressure from various people to do that.
And we have those elevated that's a mouthful. We have those elevated expectations, and I already told you about the priorities chasm and the way of working chasm between the teams. But those two weren't deadly. The deadly part was when we mixed it also with complex designs. And why did we need them? With the LLMs, the way of delivering the services were different. The architecture became different. Instead of batch processing, we started using a lot more of live processing or even streaming. And because of this, we were trying some more complex designs to our doom. Because the confluence of those three things led to the disasters I mentioned at the beginning. The first one was very innocent. It's a very simple service. It receives a message from PubSub. It sends a message to PubSub, and it calls LLM. And it is robust because it's retriable and it's idempotent. So it's a gold standard of services, right? Please code like this. Because when it crashes, even when it runs out of memory, we just retry and we reprocess the same message. But what happens if the failure is after calling the LLM. We'll retry and we'll call the LLM again and again and again and again. And maybe the service is idempotent, but our wallet isn't. And of course, all the tests are green, but our cloud billing screams red. And this is exactly how we paid $200 for a single click on a test service. Because we wanted to test something, we started the test, and then it retried and retried and retried and retried and retried. And on the Monday, we realized that it was pretty an expensive test. And it wasn't the only place where we were burning money. We deployed to production another service that was calling LLMs, and it was very successful. People started using it, and we realized that we can't afford it. We didn't have a cost model before releasing it, and we had to cancel it. I mean, we literally removed the integration code to be sure that nobody uses it. It was the first type of failure, the money failure. But there was also classical engineering failure. We wanted to host a small language model on the GPU. To do it in the right way, you need to process in large batches on a GPU. So we had the processor service that was on the GPU, and then accumulator service on CPU. The only reason for accumulator was to create the batches, and when the batch is large enough, wake up GPU and process the batch, so that's effective. And those services were correct because the results were correct and everything was all right. I integrated it with the backend and I started testing, and I realized that the results are correct, but it's kind of weird and very slow. And I noticed that there are a lot of messages sent back. I didn't know why is that, because I didn't know how those services worked. And I realized that for every message I sent, I received 25 messages, which is odd, right? What happened? So PubSub, we screwed up in PubSub integration, and it was retrying because of the timeouts. And PubSub has 5 retries per message by default. So I sent a single message, and then it was retried 5 times. And so 5 messages was sent to processor, and it was retried 5 times there. So I received 25 messages as a result. It was a very simple mistake. It was just written in the docs, and yet we had to rework this. We were late. We learned our lessons, and we invested then in the engineering side of it. So it was no longer cracks. There were no longer cracks, no longer a chasm. It was a void, and this void stopped us from moving forward. There were some uneasy questions that we weren't able to answer properly. If something failed, we didn't know who to ask to fix it because it was between the teams. We didn't know very often if the features was working okay, because we had gaps in observability. We didn't know how to debug it because of poor dev prod parity. And finally, the stakeholders were chasing us to explain the cost of the features. It was pretty bad. And out of the ashes of this crisis, something interesting was built because, of course, the life went on and we had to build another feature. The deadline was strict. The path was unclear. We didn't know how to do this. And we had this kind of low confidence. So we decided to switch gears and work in a very different way and start. And because of the environment was messy, it was no longer a relay race. It was something very similar because you still had to put a thing through a white line, but it was messy and we were badly battered. And we started working more like a rugby team without a plan, but based on cooperation than a relay race team. And first thing first, we focused on what is important for the end user and for the product. So we started measuring not only F1 and test coverage, but also the product metrics. So we are able to answer the product questions quickly. To bridge the chasm between the teams, we started regular sharing sessions for us to understand better the data science and for data scientists to get the good grasp of engineering practices. And there were no strict plans about implementation, but rather cooperation to deliver. To do this, to do the right things, we also focused on provided good tools that were like Lego bricks that help building. Instead of messy integration, we used integration framework, orchestration framework. Our workflows worked very well in this case. We started measuring costs strictly, and because of this, we were able to predict the cost in production because we had a very good cost model that worked. So we knew exactly how much the feature will cost. Then we were testing inside the product with the alpha users before the release on clone data on a safe environment. And because of this, we knew that the new feature is relevant. And finally, the tools weren't just technical gimmicks that were nice. The tools were really improving the way that we communicate within the team. And that's how a new model of cooperation appeared.
Yeah, and to build on what Maciej just said, essentially the solution that emerged, and it wasn't like a grand plan or anything, because we didn't know the project would work. So it's still like fresh learnings for us. But having shared artifacts, not this sort of very artificial boundary of like, this is DS code, these are our microservices, that's engineering. But having sort of these joint responsibilities, and I don't just mean like sort of, oh yeah, we have meetings with product and therefore we're in it together. No, we've had those for like 8 years. That's not the point. But sort of shared ownership of the experience of the whole project and the code base. So one of the things that I, for example, lost track of at one point was like, which bits are DS and which bits are engineering? And I kept having to ask like the team, both engineering and DS, what are we actually doing? But I think, and at that point, I felt very uncomfortable as a manager. It's like, okay, wait, so who's doing what? But then the end experience was actually like a really, really amazing product with a lot of impact, even financial, after a couple of weeks. But also the fact that we all sort of had much more understanding of what was going on. And for the first time, at least in Chattermill's history, I actually understood much more of the whole system as the data science leader, which obviously was like great for me personally. So this idea of like mutual sort of intelligibility like is super important, even when you have very specialized teams. So in terms of the new model, we sort of say bilingualism over translation, sort of supporting each other over the teams, and not just like artificial like sort of surface level meetings, but like deep sharing sessions of this is what we in DS care about, this is what engineering care about, these are best practices. The epistemic freedom to still have a blast radius, because for example, when I'm working on research code, I don't want to worry about breaking something in production. That is not my expertise. That is not the expertise of many of my data scientists or ML engineers. So working with these clone orgs was extremely helpful for us to still explore a lot of different ideas, but then critically optimize for this long feedback loop where we're not trying to optimize for an F1 metric or test coverage, but we're trying to optimize for really what our users care about. A very simple example is I've been obsessed with F1 score because for classification problems, that's what we've all been using for decades. But users don't care about F1 score. And in fact, they don't see most of the data. They don't see all the data. You calculate F1 on the whole data set. But what if they only see 1% of the data, right? Then your F1 kind of needs to be based on that 1%. Now, as a data scientist, that's really bad maths. But from a product perspective, that's actually exactly the signal we needed to understand what was going on. And that is the sort of bigger feedback loop, which is like really testing what actually users are interacting with. So this sort of idea of offline evals and like Streamlit, etc. I love Streamlit, by the way, but are not always helpful. But production eval is really the sort of ground truth of experiences. So to end, I would summarize as a sort of ship the feedback loop, not the demo. And thank you very much.
Right. So thank you very much to our speakers. Anyone got some questions to ask? Oh, I see a lot of hands. No one? Okay, so thank you very much to them again. Thank you.